generating principle employed on the fellows gear shaper is similar to the action of two gears rotating in mesh. The cutter is, in effect, a mating gear, having relieved cutting edges. It is reciprocated as it rotates in harmony with the work. This same principle is used in all types and sizes of fellows gear shapers, which have capacities for cutting gears from 1/16 inch to 120 inches diameter and from 200 to 2 diametral pitch. The 7125A gear shaper has been selected to illustrate basic principles and demonstrate the simplicity of setup and operation. In cutting accurate gears, control is of paramount importance. One element of control is the gear shaper cutter, which is completely ground to a high degree of accuracy after hardening. The reverse taper work arbor is inserted in the work spindle and normally is indicated to make sure it runs true. When located on an arbor, the work is usually clamped between two plates. The cutter is mounted on the cutter spindle with the cutting face down to cut on the push stroke. The required length of stroke is set by adjusting the position of the eccentric on the crankshaft head. To position the cutter travel relative to the work, the cutter is raised above the work. Then the crank arm is adjusted and the position of the cutter checked at the top and bottom of the stroke. The indexing mechanism is of the continuous revolution type, separate index wheels and worms driving cutter and work. The ratio between the numbers of teeth on cutter and work is maintained by change gears. The feed per stroke of the cutter is controlled by change gears driven from the main drive shaft. To set depth of cut, the feed cam is turned until its high side contacts the roll. This face clutch is released and the worm shaft turned to center a cutter tooth with the work. The cutter is advanced until a feeler gauge of known thickness can be inserted between the end of the tooth and the blank. The micrometer collar on the depth feed shaft is set at 0, the cutter raised above the work, and the shaft rotated to feed cutter to depth. The feed cam is turned until the roll drops into the depression. This completes the setup operation. Positive control over direction of cutter reciprocation is affected by guides. Straight guides are used when cutting spur gears or straight surfaces. Helical guides are used for cutting helical gears. Each guide has the same hand and lead as the cutter to be used. In operation, a twisting motion is imparted to the cutter as it reciprocates and rotates in harmony with the work. The addition of various work-holding fixtures and accessories for cutting racks, internal gears, and face gears makes the gear shaper a very versatile machine. Internal gears are generated by using an operating arm extension, moving the saddle to the right of center and rotating cutter and work in the same direction. Face gears, either on-center or off-center, and clutches can be cut on this universal type attachment. The work spindle is located in the horizontal position relative to the direction of cutter travel and is driven by change gears. Many different forms can be produced on a gear shaper equipped with the proper accessories and cutter. Cutters can be made in many shapes and sizes to produce regular or irregular forms, either external or internal. An interesting example of gear shaper versatility is shown here in cutting an external and an internal helical gear in the same part. A 6A type machine is shown cutting the external. Aside from setting the cutter to the work, the only change necessary to cut the internal is to install the proper change gears and an idler, so cutter and work will rotate in the same direction. Both gears have the same pitch, helix angle, and hand, so they can be cut at the same work setting. The number 4 AGS is especially adapted to cutting close tolerance gears at high speed. For more rigid control of the cutter spindle, the size of the guide has been increased. 4-inch cutters are used. The machine capacity is 6 inches pitch diameter and 2 inches face width. A special variable speed and feed unit which automatically changes rates of speed and feed between roughing and finishing cuts is available. The number 4 AGS can be arranged for manual, semi-automatic, or full automatic operation. To utilize its production speed to the greatest advantage in the smaller size range, the number 4 AGS is designed to facilitate the addition of magazines or other work loading and unloading devices. Here's an example of a relatively simple arrangement. The gear blanks are placed in the inclined loading chute by hand. They feed down the chute by gravity to the magazine slide, from which they are automatically located and clamped on an arbor. After a gear is cut, it is stripped from the arbor by stripper fingers and ejected into the unloading chute. Automatic loading and unloading of this transmission shaft requires a more complicated arrangement. The shaft is handled by 2 sets of air-operated fingers mounted on a turret. As the turret turns from one position to the other, one set of fingers moves the finished piece to the unloading chute, while the other set brings an uncut shaft into cutting position. The operation is fully automatic, except for placing the shafts in the loading chute and removing them from the end of the unloading chute. Here you see a line of 4 number 12 gear shapers in production, side trimming the slots, which form an internal spline deep in an automatic transmission case. They are fully automated and are equipped with a conveyor for moving the parts along the line. As soon as any machine completes a part, it stops automatically, and the bed carrying the cutter spindle rises. All clamps, except the set holding the piece in the loading position, are released. The carriage places the finished part on the conveyor and waits for another part. In a few seconds, one arrives, and the loading cycle starts. The carriage moves the part to the fixture where the machine clamps it. As soon as the carriage unclamps, it signals the machine to start its cycle. Additional work clamps are applied, and the part is accurately located with respect to the cutter teeth. The locator retracts, and the bed lowers to bring the cutter into proper cutting position. The cutting operation consists of side trimming the sides of slots, which are cast in the case to form an internal spline. The cutter has the same number of teeth as there are slots, but the teeth are narrower. After the cutter is lowered into the work, it reciprocates as it slowly turns clockwise to trim one side of the slots. Then it is returned hydraulically to its starting point. It is next turned counterclockwise to finish the other sides of the slots, and again returned to the starting point. At the end of the cutting cycle, all locking wedges are retracted, and all but one set of the clamps released. The part is then returned to the loading position, so it will be aligned with the carriage. The machine now signals that it is ready to unload, and the cycle repeats. One of the larger capacity heavy-duty machines is the 36 type gear shaper. It will cut spur or helical, internal or external gears up to 36 inches pitch diameter and 6 inches face width. The spur gear being cut is 3 diametral pitch with a face width of 5 inches. This cut in SAE 1020 steel is 750 thousandths of an inch deep, with a rotary feed of 27 thousandths of an inch per stroke of the cutter. The rigidity of this gear shaper makes heavy cuts possible, as evidenced by the size of the chips you see here. Another application of the gear shaper cutter is the generating of threads and worms. This is a so-called straight worm generated on the number 4T thread generator. The principle employed is similar to that of rolling a gear in mesh with a rack. The cutter is kept in harmony with the work by a differential gear mechanism as the cutter is traversed to generate the worm threads. Here is an hourglass worm used in an automobile steering unit. The gear shaper cutter is used in a different manner in cutting this worm. Owing to the hourglass shape, the cutter is not traversed but is fed directly into depth as it rotates in harmony with the work. This is the number 6T hourglass thread generator. Fellows gear shapers and Fellows Fouter gear hobbing machines are perfect complements and provide complete coverage of modern gear production needs. Both operate on the molding generating principle. Fellows Fouter gear hobbers are built under license from the Hermann Fouter Hobbing Machine Works of West Germany. They are designed for high-speed hobbing and incorporate the latest results of research into vibration behavior. There are several sizes of these machines. This is the P400. It is in the medium size range and will hob gears up to 16 inches diameter, 11 inches face width, and 4 diametral pitch. Maximum hob diameter is 6 1/4 inches. Hob speeds are infinitely variable between 80 and 500 RPM. Continuous hob shifting, developed by Fouter and called diagonal hobbing, is one of the features. Automatic step-by-step hob shifting, taper hobbing, crown hobbing, automatic two-cut cycle, and automatic loading attachments are available as extra equipment. Gear finishing processes are used to refine the accuracy and surface finish of gear teeth, either in the soft state after cutting or after hardening. 3 of the principal processes are gear shaving with a serrated tooth gear type tool, gear finishing with a cutter having all cutting edges located on one face, and gear grinding with a profile grinding wheel. The first 2 are for gears in the soft state. In gear shaving, the axes of tool and work are set askew to each other for shaving external spur and helical gears. Shaving tools have a multiplicity of serrations cut in the involute profiles, or they are slotted, depending on the pitch. The sides of the serrations are the cutting edges. Cutting action depends upon the skid of these cutting edges and theoretically takes place at the point of intersection of tool and work axes. Fellows shaving machines employ 3 different methods. Conventional crossed axes shaving for external gears and for internals where design permits. Full tool or diagonal crossed axes shaving for external gears. Parallel axes shaving for internal gears. The number 8 full tool shaving machine can be used for either conventional or diagonal shaving. Let's observe the positions of tool and work relative to direction of tool reciprocation and necessary lengths of tool travel. For conventional shaving, the tool axis is set at an angle to the work axis, and tool reciprocation is parallel with the work axis. The upper model represents the tool. The scratch mark is the point of intersection of the axes. This point remains constant on the tool as it reciprocates, showing that the cutting action is localized. The movement of the pointer shows that the minimum length of tool travel must equal the full face width of the work. To show the cutting action, a tool having single cutting edges is applied to the work. As the tool turns and drives the work, the cutting edges skid endwise and remove metal by For the diagonal crossed axes method, the work fixture is now moved, so the axis of the work, as well as that of the tool, will be at an angle relative to the direction of tool reciprocation. The point of intersection of the axes at the start of tool reciprocation has been changed from the center to the back edge of the tool. As the tool is reciprocated, this point continually changes its position on both the tool and the work, showing that the cutting action is distributed over the entire face of the tool. The maximum length of tool travel required is much less for the same face width than that required by the conventional method. The number 8 full tool shaving machine is shown here, shaving an external helical gear. The shaving tool is brought into contact with the work under pressure. The tool rotates the work and is slowly reciprocated. The direction of rotation is reversed at each end of the stroke to finish both sides of the teeth. Fellows build several types and sizes of shaving machines, with capacities from 1/16 inch diameter, 100 pitch, to 24 inches diameter, 4 pitch. The number 4 BGF gear finisher employs the conventional crossed axes method. Hardened and precision ground gears in the work spindle assembly effect and control the relation of cutter and work in terms of their respective numbers of teeth. The helix angle is controlled by a helical guide. The cutting tool has all cutting edges located on one face and is similar in concept to that of a fellow's gear shaper cutter. In the sequence of operation, the work is placed on the arbor and clamped at low pressure so it can turn with the cutter to align the teeth. The motor is started to rotate cutter and work. In actual operation, it also starts the flow of cutting oil. As the work moves to the cutting position, the teeth are aligned and the work clamped solidly. The cutter feeds into depth and the work traverses past the cutter. After the cut is completed, the cutter moves to the back off position and the machine stops. The third finishing process is gear grinding, which is used principally for hardened gears. Precision gear accuracy, fine finish, and high-speed grinding are achieved on this number 12 Fellows Reischauer gear grinding machine, which Fellows builds and sells in the United States and Canada under an exclusive license from the Reischauer Tool Works Limited of Switzerland. Gear grinding on the Fellows Reischauer is a generating process, whereby the tooth shape is generated by a grinding wheel on which a helix has been developed. The tooth section of the wheel is usually that of the basic involute rack. In operation, the involute is generated as the grinding wheel rotates in harmony with the work, while the work, carried on a work slide, moves actually by the wheel. Differential gears provide the additional rotary movement required when grinding helical gears. The wheel and work spindles are driven by synchronous motors. Grinding is done in both directions of travel of the work slide. The 1-inch face width helical gear you see on the machine has 30 teeth. It is rough and finish ground in about 5 minutes. It is obvious that only a small portion of the usable width of the wheel is used during a normal grinding operation. By means of a tangential shifting device, the work can be positioned along different portions of the wheel face to make use of its entire width and thereby greatly increase wheel life. For crowning gear teeth, a mechanism which rocks the gear actually as it passes by the wheel is built into the machine. The amount and location of the crown are controlled by cams attached to the work slide. Wheel dressing or truing devices can be mounted on this slide to prepare the wheel for grinding. This universal diamond truing device will dress the wheel to produce either true involute teeth or teeth with tip or root modifications, or both. This is our main plant in Springfield, Vermont, a relatively small town, but one which has gained a worldwide reputation because of the precision machine tools produced here. Our company was organized in 1896 to manufacture a machine and a cutter which represented E.R. Fellow's original development in the art of cutting gears. Today, we produce a complete line of gear production equipment, and our engineers are always ready to help you with your gearing problems. This will undoubtedly become a familiar scene when you visit us in Springfield. The Hartness House is a truly fine country inn that is noted for its comfortable, home-like atmosphere and the excellence of its cuisine. It is located amid beautiful surroundings in a residential part of the town, and the main section is the converted mansion of a former governor of Vermont, the late James Hartness, after whom it is named. Business and pleasure can be combined because of the opportunities to engage in your favorite seasonal sport, no matter what it may be. Not far from the inn is the Crown Point Country Club. Here, golfers can drive away their cares on an 18-hole course, which offers unsurpassed scenic views, especially when autumn adds color to the beauty of the foliage on the surrounding Vermont hills. It could be that this chap's form isn't exactly professional, but he is having fun, and that's the main thing. There's another green above, from which you can look down and across the valley to the southwest. As far as you can see, there are rolling hills. Trees are everywhere, and all but the evergreens show the beautiful red, yellow, and gold coloring that autumn gives to the Vermont forests. Now and then you see an ardent golfer traveling by himself and engaging in some serious practice. Everything he needs is in that electric golf car, so he should be able to devote all his attention to his game. Here is a young lady who was unaware that anyone was near. We decided to watch her form to see if it was different from those previously seen. It was. Directly ahead is Mount Ascutney, a little over 3,000 feet high. In winter, there is excellent skiing at the Mount Ascutney ski area on the north slope of the mountain. After you leave the club, you can drive leisurely down the country road and discover many beautiful views. You can stop anywhere to enjoy them because there won't be any traffic problems. On the way back to Springfield, down in the valley where the Black River flows, swift running water sparkles in the sunlight as the river runs its course through the hills. This might inspire some of you to think about overhauling your fishing tackle when you get home. Farther along are stretches of deeper water where the river's pace is slower. Here the trees come to the edge of the water and at times seem to be growing in it. About 3 miles above Springfield, there is a flood-controlled dam on the Black River. And on a bright fall day such as this, the brilliance of the foliage is reflected on the still water back of the dam. Now, you're just across the river from the Fellows Gear Shaper Company plant, where you are always welcome. We would be highly pleased to have you visit us whenever you have the opportunity.